introduce Cynthia in just a moment, and then she'll start sharing her slide. She is going to talk about the geologic hazards. It's basically a shortened version of a talk that she and I gave a little over a year ago, I think. Cynthia is a full-time resident of Teton County. She has bachelor's and master's degrees in geology, of course, from Duke and Rice universities. Parent of 3 children who have been going to school here in Jackson Hole, and she considers herself a lifelong learner. She has 3 decades of corporate experience with British Petroleum, BP, half of which in technical roles, half in managerial roles. Her hobbies, it's a nice list: reading, geology, hiking, biking, Nordic skiing, downhill skiing, yoga, cooking, and traveling. I think probably only the skiing and traveling are sort of coming to an end or on hold right now. So without further ado, I'd like to ask you to join me in welcoming Cynthia Blankenship. And Cynthia, go ahead and fire up and share your show.
Thank you, John. So as, hang on a minute, guys. So as John mentioned, this is going to be a summary of a talk that John and I gave last year in April. And the reason that I'm motivated to do this as a summary talk is because there were technical issues with recording the talk when we gave it last year. And I thought that the subject matter was too important to not have a video of it on our website. So hence this shortened version of our talk. So this slide will serve as an outline for the talk. And basically I'm going to talk about the possible geologic events in this area, starting with the low probability but high impact Yellowstone Supervolcano eruption, all the way down through Teton Fault rupture to landslides and to the very frequent but potentially deadly, but relative to the others, low impact event of our snow avalanches that we have every year. So starting with the Yellowstone Supervolcano eruption, Bob Smith has calculated that the probability of that happening in any given year is 0.00014%. So extremely, extremely unlikely. But let's dig into that for a minute. So in the past 2.1 million years, there have been 3 supervolcano eruptions in the vicinity of where Yellowstone is today. The first one was the Huckleberry Ridge eruption, or caldera forming eruption 2.1 million years ago, followed by the Mesa Falls caldera 1.3 million years ago, and the most recent being the Lava Creek eruption 640,000 years ago. And these 3 eruptions caused ash deposits over a huge area of the United States. The biggest one, or the one that had the furthest distribution of ash, being the Lava Creek tuff, which was the most recent. So the impact of such a super eruption could range from a very fast moving current of very hot gas and rock called a pyroclastic flow in the vicinity of the volcano. And the range could also include ashfall. As we've seen, the ashfall from the last 3 major eruptions of Yellowstone covered a huge portion of the United States. Here's another example. This is an example of an eruption from the Bruno Jarbidge caldera, which is one of the ancestral Yellowstone eruptions, and it killed rhinos over 1,000 miles away at Ashfall Fossil Bed State Park, Nebraska. And that occurred about 11 to 12 million years ago. So what is the probability, though, of a super eruption? In order to understand this, we have to look at the entire history of the Yellowstone caldera forming eruptions. And these started 16 million years ago with the McDermott caldera. And since then, the Yellowstone hotspot has been traveling to its current position in northwestern Wyoming. And along this trail, super eruptions have occurred roughly every million years. And the last one, as we talked about, the Lava Creek, was 64,000 years ago. Given that, you can do the math, it's very, very unlikely that a super volcanic eruption of Yellowstone will occur in our lifetime. I would say the odds are vanishingly small. So now let's move on to the Teton Fault rupture. Again, Bob Smith has calculated that the probability of the major rupture of the Teton Fault occurring in any given year is 0.123%. So more likely than a Yellowstone supervolcano eruption, but still extremely small. So what we're going to do in this section is we're going to look at data from Jenny Lake cores. Well, let me orient you first to this map. So this is a topographic map of the southern Jackson Hole area with the Teton Range here and the Teton Fault shown, the fault trace shown in red, Jackson Lake, of course. And so we're going to be looking at core data from Jenny Lake that was published in 2019, and also data from a trench that was dug in the Jackson Hole Mountain Resort, Buffalo Bowl, to look at what they found in that trench that went trenched right across the fault trace. Okay, and then what we're going to do is we're going to also look at some of the microseismic, small scale seismic data throughout this area, and talk about what the oopsie, sorry guys, that circle moved. That circle for the Jackson Lake Dam should be over here. Sorry about that. Okay, so let's first talk about the Jenny Lake cores. So Jenny Lake was formed during at the end of the last glacial period, around 14,500 years ago. And what the cores reveal is that periodically there are pulses of higher concentrations of sand in the cores and higher density of that material. And so presumably these events that are producing these coarser grain, denser sediments are faults, rupture instances of the Teton Fault. And so what you notice is that just after the last glacial event, there was quite a lot of activity on the fault, and since then it has been much, much more muted. And one good hypothesis for why this is that the early history of the fault was active because of isostatic rebound. So basically the ice sheets and glaciers melting and the weight of that being alleviated, the Earth's crust could then rebound. And so let's look now then at the next study, which was the trench across Buffalo Bowl underneath the Jackson Hole Mountain Resort tram line. And then this study was published by Du Ross et al. In 2019. I believe the trench was dug in 2017. And so what they trenched was an alluvial fan, and the age of the alluvial fan, so sediments basically on top of bedrock, and the age of the alluvial fan is shown in this purple dashed line, which is 10,500 years ago. So that's the oldest faulting event they could have recorded. And what they actually found in the trench were 3 slip events, so 3 earthquakes basically. Each of them, the offset was about 2.1 meters, and they occurred here where these solid purple lines are. So one at about 10,000 years ago, one at about 7,000 years ago, and one about 4,500 years ago. Now, the timing of these slip events do not really line up with the ones we see in Jenny Lake, but that's not hugely unexpected because the Teton Fault is actually made up of fault segments, and depending on how the strain is accumulating locally, the different segments can fail at different times, kind of like the San Andreas Fault. It doesn't all, the whole thing doesn't just rupture all at once. But to go further, what Du Ross and all were interested in was the rate of slip of the Teton Fault. And so in this time period that they studied, well, basically 10,500 years ago to present, what they found was 3 events in this time period, which calculate out to a slip rate of 1.1 millimeters per year. What they also did was looked at previously published data from the Cascade Canyon area. And what they found there is that the slip rates were higher. So in the early stage of the Teton Fault in that area, they were more like 2 to 3 millimeters per year. And then, of course, in their trench, the youngest rupture event was 4,500 years ago. So since then, there have not been any faults. So both of these, if you sort of step back, both of these studies indicate a big reduction in slippage of the Teton Fault in the last 4,000 or so years, which could mean a couple things. It could mean that we are in a period of quiescence because the effects of the isostatic rebound have happened in the past. But it also could mean that we're basically accumulating some strain along various portions of the fault, so it still may rupture. So this is there's certainly a possibility that it could still rupture. Okay, now here again, let's just orient to this map. So here is the Jackson Hole area. Jenny Lake is in blue, the Teton Fault is in green, and now the Jackson Lake Dam is in the right position. That's good. All the red circles are small, very minor seismic events or earthquakes. The biggest one is a magnitude 4. So even in the 2s and 3s, sometimes somebody might feel them if they're in the right position, but even up to the 4, very little, if any, structural damage. So these are really very minor events. Nevertheless, the Bureau of Reclamation was able to take the data from these measured seismic events and make a 3-dimensional model of the Earth. And when they did that, what they found was that sitting underneath Jenny Lake and the Jackson Dam is a very low velocity basin. And we're going to talk a bit more about this and why that's important. So here is a picture of their model, a map of their this is a map of the data of what they found. And what it shows is, again, here's the Teton Range, and green is the Teton Fault. And the very low velocity zone that they found is in this shaded purple and gray area, with the Jackson Lake Dam located right in the middle of it. And this very low velocity zone is over 2 miles deep, and it consists of lake deposits from an ancient Jackson Lake, which was much larger than the current Jackson Lake, as you could see on this previous picture. So that was the extent of the Paleo Jackson Lake. So why is this important? Well, this very low velocity basin will trap, hold, and amplify seismic energy in the event of a large earthquake. So let's look at that a little bit more. So here is the modeling that they did of the low velocity basin. So think of this rectangle here as 3-dimensional with a beveled edge. So this white part of this 3-dimensional rectangle is beveled. And if you look at this cross section from north to south, this is that beveled edge. So that's this edge right here. Whoops. This cross section is the east-west in here. And again, this beveled edge is this piece here. And it is also the edge where the Teton Fault is located. And then again, we have another bevel going from south to north in this lower cross section. And here's the important thing. So the velocity inside the basin is extremely low and is much lower than the velocity of the rock outside the basin. So the importance of this modeling is that what they show is that they're over a very large range of incident angles that could enter this basin. So for example, by a fault in the Teton Fault, over a very large series of angles, the energy that enters this basin gets trapped and starts bouncing around inside the basin. And as it bounces, some of these waves, basically they're waves of water, could constructively interfere with the result, or even the waves themselves, resulting in potentially dam failure. Okay, so now let's look at what this looks like geologically. So we're going to look at a cross section that goes along the Jackson Lake Dam. So the Jackson Lake Dam has several elements to it. The first, as you know, is the concrete part of the dam, which is the spillway. So that's that white. This is the white, which is the water rushing through the dam and exiting to the Snake River. But the other part of the dam is what's called the earthen part of the dam, which is compressed earth. And there's a bit of it to the south of the dam, but there's a big section of the dam, this compressed earth part of the dam, sorry, hang on a minute, that's shown here. So what we're going to do is we're going to look at a cross section that goes from north to south along the dam. So that cross section shown in yellow, and it's shown here sideways. I'm going to flip it around in a minute, but this is just to get you oriented to it. And here's the concrete part of the dam. Here's the concrete part of the dam. All right. So let's flip that around now, and let's look at the different elements. So this southern dam embankment, or compressed earth part of the dam, is shown in yellow, but this is the concrete part of the dam, relatively small compared to the entire dam. And this concrete part sits on the Huckleberry Ridge Formation, which is a hard, competent formation. So that's good. The next part of the dam is the earthen dam, which is shown here in yellow on both sides of the dam and extending quite far to the north. And that's what we saw on the Landsat image. The next part is in 1987, as part of the dam construction, the Bureau of Reclamation compacted the top 40 to 100 feet of lake bed material to form support for this southern portion of the earthen dam. However, that compacted lake bed sediment sits on top of this green layer, which is fine-grained, water-laden sediment. The importance of this is that it could liquefy in the event of a large shaking event. So basically, this top 600 feet of sediment, 600 to going down to very small thickness, could act like a liquid. Now that is sitting on top of, as we'd already discussed, the low velocity basin. So underneath all this potentially liquefiable material sits this low velocity basin, which goes down another mile and a half or so. So basically what we have is this low velocity basin, which is going to be trapping seismic energy and making it very difficult for that energy to escape and bouncing around in there. And on top of that is going to be 600 or so feet of material, water and sediment that's behaving as a liquid. Okay, so one more thing to point out on this cross section is that there's a zone in here shown in this red rectangle that the Bureau of Reclamation calls Site Response Transition Zone. And this is underneath the concrete portion of the dam, which is over here. A strong earthquake of magnitude 7.5 would result in ground motions equivalent to a magnitude 8 earthquake for at least 80 seconds. And under the earthen portion of the dam, so all this yellow, it would result in ground motions equivalent to a magnitude 9 earthquake for 180 seconds. Now, the interesting thing is that this transition zone would be subject to both of these motions. And again, with the possible result of dam failure. So this is not highly likely, but let's just look at what the impact would be of a dam failure. So in this map, here we are at the Jackson Hole Airport is up at the top here. The town of Jackson and the airport would be spared. Wilson and the Snake River floodplain, not so much. You can see in the orange and the red that this would be the extent of the floodplain. Okay, so let's move on to a more common feature of this area, which are landslides. So this is a map of Wyoming. It's a map of paleo landslides, basically, in the area. And you can see that there are more mapped landslides in Teton and adjacent counties than all the rest of the state combined. So it is a very frequent, landslides are frequent occurrences here. And just to give you a few examples, here's a photograph of the Lower Grovant slide from 1927, which dammed the Grovant River and has got a fault scarp of about 2,000 feet tall. And then we have the May 2011 landslide in the Snake River Canyon that closed the highway for over a week, going down into the Snake River. Here's some cars for scale. So again, a huge, huge event. And then finally, we have the famous Walgreens slide in April of 2014 in the town of Jackson. So let's now look at our most frequent events, which are snow avalanches or snow slides. Let me just point out here that in the event of a Teton Fault rupture, these two, in the event of a winter Teton Fault rupture, would be there would be many more of these slides, and importantly, they would occur all at the same time, triggered by the Teton Fault. So that could be really a devastating outcome. And in fact, here's a map of southern Jackson Hole, which shows all of the areas that could potentially be isolated from each other due to bridge collapse, snow avalanches, or landslides. And there are 18 of these so-called islands in the area. Not saying that they would all be isolated at the same time, but many of them could be. So how do we prepare? And this is the last slide. For those of you who remember the talk originally, I think Dan O's would recommend that we be prepared at all times for two weeks of isolation for food, water, medicine, everything. And I guess I think right now, given our current pandemic situation, we're in some ways well prepared because we have very few, if any, tourists here. So we don't have to deal with the massive extra number of people. I think everybody's also practicing stocking up. So everybody has probably more food at hand than they normally do. However, of course, any kind of geologic event coupled with the coronavirus could be really very, very devastating in a number of ways, psychologically, physically, more people getting sick, strain on resources, strain on emergency responders, that sort of thing. So I will stop there and happy to myself, John, or Rich field any questions you might have. Thank you.
Okay, Cynthia, thanks for that. Let's see. So if people have questions for Cynthia, for Rich Ochs, or myself, please go ahead and use the chat option and go ahead and type those in. They'll show up. And I have a couple here. And Cynthia, I don't know whether you can answer this. I can. And that's how somebody asked how many seismometers, what's the seismic grid that's located around Jackson Hole?
I don't know that, John.
Okay, it's around a dozen or so, and which is really part of a much broader seismic network. So when you look at an event map like you showed earlier, Cynthia, with all the red dots of seismic events, that represents data from literally hundreds, depending on the size of the earthquake, hundreds of measurements from a wide grid of seismometers. So, but there are about 10 or so in the immediate Jackson Hole area. And let's see, there's a question. Would there be fluidization underneath the dam during an earthquake? You basically answered that, and the answer is quite likely yes.
So the concrete part of the dam is built on solid rock.
It's tied into the Huckleberry Ridge Tuff.
Yeah, but the important earthen part of the dam is built on top of sediment that could liquefy.
So there's another question here. What do you think the impact, and this is for you or maybe Rich Ochs, what do you think the impact on our electrical grid would be for some of these scenarios? How redundant is the electrical supply system coming into Jackson Hole?
I can field that. As you all know, that our grid has gotten much better in recent years, probably in the past 20 years. We don't get nearly as many as power outages. Lower Valley Energy, we work with them pretty closely on planning for this, but there's really 3 routes for power right now into town. So we have 2 lines that come over Teton Pass, and then one that comes up the canyon. And as we've seen, I mean, not even for a seismic event, but if you remember the wildfires that we had in Idaho, what was it, 3 summers ago now? The Ty Creek fire, and then the Henry fire in Idaho Falls. Both of those threatened. We have 2 points of failure that could take out all the power in the valley, and they threatened both of them simultaneously. So yeah, there are issues there. Luckily, Lower Valley got approved. The environmental impact statement was approved for running the extra line through Soda Springs and coming up over there, kind of getting us away from an incredibly critical single point of failure in the state of Idaho that not only would impact our grid here in Teton County, but most of western Wyoming. So they're working on redundancy, but I would say that it's something that concerns us. But they're big infrastructure projects would have to take place in order to get rid of that, or to get rid of those vulnerabilities.
Okay, Rich, there's another question here that probably is for you. And it's, if one has water stored, does that water have to be changed periodically? In other words, on an emergency basis? And if so, how often?
Yeah, I mean, we get that question a lot, and generally there's expiration dates on water bottles and stuff. I tend not to follow them. If you keep it in a temperature-controlled environment, so if you're keeping it between, around 70 degrees or a little less than that, out of direct sunlight, mostly it's the leaching of materials from the container that it's in. So in a plastic bottle or something like that, you don't really want to let it sit, and the water kind of tastes funny after a while. But some containers are a little better; they leach less. So like your 5-gallon water cooler type bottles tend to be pretty stable. That's actually those 5-gallon containers are what we use in the Emergency Operations Center. That's what we store in here. We rotate through them probably annually. They're relatively cheap, so we keep probably 30 to 40 gallons of water in here, and then we just rotate through it if we don't drink them. But I would say at least every year. Other options other than storing the water as well is a lot of folks have purifiers that work really well, stuff with filters, like a Pure or a Katadyn type of filter is pretty good. There's also Life Straw, which is a pretty cheap alternative, really simple and small to keep in a small kit. They're about yay big and relatively cheap, and that'll just filter the water as you suck through it, which can be useful as well. So there's other alternatives out there. And then bleach. So using 1 to 10 mixture of bleach and water, just so there's a slight hint of chlorine smell in the water. That makes sure that you know that you killed it. You can let it sit for a while, and that'll generally kill everything in the water.
Okay, another question here, Cynthia. This is maybe for you, and the question is just is fluidization and liquefaction the same thing?
Well, I'm certainly not an expert in this, but yeah, I would say they're pretty much the same thing.
Yep, agreed. I don't see other questions. Does anybody else have questions you want to type into chat that one of us could try and address?
Actually, there was a couple of questions that came into me. Rich, can you talk about the impacts on the roads, bridges, power, and communications of a 7.5 magnitude earthquake in the dead of winter?
Significant.
Yeah.
I think the map that the geologist Jackson Hole put together that we still use, we'd love to get that digitized and into our GIS system. But it's a fantastic map that kind of shows the effects of that, like what happens if bridges go out, the landslides come down, all the things Cynthia talked about happening at once because the ground starts moving, avalanches, things like that. So we know on a good day in the winter, we can lose our major transportation routes in and out of this valley. During an earthquake, that's going to become even worse with debris in the roads, loss of bridges and things like that. We've worked with YDOT to try to get some assessments of the bridges. They generally don't assess them for seismicity or for survivability following. They're engineered to a certain degree depending on the seismic zone that we're in. But they won't stand behind it and say this will withstand a 5.0 or a 6.0 earthquake. So the assumption that we have to go under is that those things will all go down. So in the winter, of course, it's even more complicated because getting people to any type of shelter would be difficult at best. And that's why we really push, like Cynthia said, 2 weeks of preparedness. I think if we told people before this whole COVID pandemic thing that we wanted them to prepare for possibly, not having their jobs or being able to go to the grocery store or doing these things for 2 weeks, we get laughed at. But now we're going on 30 days, and this is the reality. And so it's long duration. We used to push 3 days. The state and the feds kind of recently, within the past couple of years, kind of switched to this 2 weeks ready idea that you really need to be prepared for at least 2 weeks self-standing. And out here, I think most people live in Wyoming understand that. Help is a long ways away. And then we're looking at an incident like this with COVID, for instance. Every other jurisdiction has the same problems we do, if not worse. So we can't always assume that our mutual aid partners will be available. And during a large earthquake, our mutual aid partners in Idaho will probably be impacted as well. So that would be, it would have a significant impact. That is kind of the nightmare planning scenario, exercise scenario that we use.
Well, where do we tune to for information in case something like that happens? What's the?
You'll know if there's a 7.0 earthquake.
No, I mean for what to do and etc. Like, is there a?
So there's several. I mean, it depends on how the infrastructure is impacted. So, there is the possibility that cell phones will still work. If they do, we have wireless emergency alerts. So that's a way that we have issuing alerts to the public. So right as this whole COVID thing kicked off, there was a wireless emergency alert sent for the public health orders that initially came out from Dr. Riddell. So, your phone makes that crazy noise. The nice part about wireless emergency alerts is that it runs through FEMA's system. So emergency management is the agency that's responsible for that, Teton County. And it is not, unlike text messages that can clog up a cell tower and have a hard time getting out, wireless emergency alerts actually travel over the data channel on a cell tower, and that's the channel that your phone uses to like sync its time with the network. So there's no bandwidth issues. So I can send, it doesn't matter how many phones are out there associated with the cell towers in the county. We can send messages and they won't be throttled by the infrastructure. So that's one way. We also have NOAA All Hazards Weather Radio, which is probably going to be the most resilient way of getting information out to the public. You could buy a very simple weather radio if you're not familiar with them. You can get them at local retailers. I know Novi sells them and things like that. You get them online. And our transmitters at the top of Snow King are not ours, the National Weather Service's transmitter, but we have the ability to broadcast over it. And the Weather Service sends messages on our behalf. And I'll say that local commercial radio stations are probably going to be something. I mean, a lot of people do satellite and stuff right now. Make sure you've got a battery-powered AM/FM radio. When we're talking about just being able to broadcast information to the public post-disaster, that's probably one of the most effective ways that we have of reaching people. It's an infrastructure that we can get up pretty quickly, even after other things have been knocked down. Cell infrastructure depends on so many other underlying things, including fiber optic networks, copper networks from CenturyLink, things like that. So many things could go wrong there. But broadcast radio and NOAA All Hazard Radio are pretty resilient. Those are the ones that I would stick with.
So Rich, just to add to that, I think I remember reading, I think it was in the Geologists of Jackson Hole pamphlet on hazards of the area, that if the dam did break because of an earthquake, we would have several hours of warning down in this area, in the Wilson area, to get to higher ground.
8.5.
If the dam does fail, here's a question. If the dam does fail, what would the water depth be downstream along, from Teton Village? Is this going to be a 3-foot flood, or is this going to be a 30-foot flood?
I think more like 10 feet in Wilson.
I'm sorry?
I remember 10 feet in Wilson.
Yep, that's correct.
Yeah, it's a very good question, because what the Bureau of Rec would typically map is flood coverage, not depth. They wouldn't do depth grids very often. So they started doing some depth grid mapping. They don't, I believe, Bureau of Reclamation can keep a lot of information from the public due to Homeland Security, because they're considered critical infrastructure. So they have started kind of looking into doing the depth grids. We've asked them if they'd be willing to release that information. They're very hesitant to release it. But the coverage map, like what Cynthia showed, is typically what you'll see. So it doesn't show depth, it just shows area. The times, the estimates, like John said, you're looking at about 5 hours to Moose, 8 hours to Wilson, and then you're looking at about 24 hours for the water to get to Idaho Falls. So I wouldn't say that you would have 8 hours of warning, because it depends on if the infrastructure is up to actually issue a warning. You would have 8 hours from a critical failure of Jackson Lake Dam. Whether you knew that Jackson Lake Dam had critically failed is another story. So for large earthquakes, especially on the West Bank, it's not just the dam that we're concerned about, it's the levee system. And we know that the levee system, the Army Corps has been very frank with us. They do not, the levees are not built to any seismic resistance whatsoever. Seismicity is not taken into account with how the levees are built. An earthquake of a 7 would definitely destroy the levees. So you would have flooding issues long before the water came down from Jackson.
So would this be a tsunami kind of, or would it be kind of gradual flooding, or how would that?
So, and that's kind of the issue with some of the models, and I think that's one of the reasons why the Bureau of Reclamation, aside from citing Homeland Security security issues, is the interpretation of that data. So some of the models, it depends on which model was done by which consultant and when they put it together. Some of them are done with a gradual failure of the dam, and some of them are done with the dam just completely disappearing, as if it just vaporized, which we know wouldn't happen. It would be more of a gradual failure. So how quickly and how high the water would come down would really depend on the stages of failure of the dam. And then I think, kind of Cynthia spoke to some of the issues that could cause more amplification of an earthquake to have the dam actually experience something stronger than a 7 on the Teton Fault. And those are all kind of part of the unknowns. So we're working in our mitigation plan that we're working on putting out. We did with our mitigation planning contractor a little bit of depth gridding. With some of it, it's not sanctioned by the Bureau of Reclamation or anything, but we're going to try to put out some data that we've created. Our plan approval process has been derailed a little bit by the COVID thing, but we hope to get that done by this summer.
I guess one other thing to remember that something we saw in Bob Smith's talk earlier this year is that Fish Creek in Wilson is topographically lower than the Snake River, which is why it could be so up to 10 feet deep in the Wilson area.
If you want to know how deep it will be, all you have to do is look at that map that shows the distribution of the possible flooding. And if you look at a topo sheet and look at the elevation there, you can see what the possible depth would be, and then you can look at the topo sheet and find the low spot that you're interested in, and you can see what the water depth could be.
Here's a question that came in. It says the Wilson Bridge is being replaced in 2023. Does anyone know what it should be able to stand seismically?
Rich, do you know?
I'll kind of go back to what I said originally, that they will not, WYDOT will not say that the bridge will withstand a certain level of magnitude of an earthquake. They say that they engineer it to the required standards based on the seismicity of the region, and they have the different seismic regions throughout the state. So we're obviously one of the highest, so ours tend to be a little more expensive and a little more robust, but they won't say that it will withstand a 6 or a 7 or anything like that. They won't let you hold them down to that number.
There's a question about, there are a couple of related questions. One is, are there any plans to tunnel through Teton Pass? I'll just answer that one. No. Is it geologically possible? You've got maybe $6 or $8 billion, maybe. Snow sheds, though? That's probably a question to WYDOT.
Yeah, definitely a WYDOT question. I know WYDOT and Cheyenne loves hearing that one.
And won't answer it.
I mean, they'll answer it. They say no. But, it's something that's brought up all the time. And they've done, Bob Hammond would actually be a great person to kind of get on a call and talk about that, our local engineer for WYDOT. And, but yeah, they do cost benefits, and they look at it, and the cost for mitigation is cheaper for them than the snow sheds, if I'm not mistaken. But don't quote me on that one. I don't want to speak on behalf of WYDOT. I know the cost is a big factor.
Okay, there's a sort of a related question. In case of a large Teton quake, would Teton Valley, Idaho be significantly impacted? Rich, maybe to you.
Outside of my jurisdiction, it's over the state line. I don't care what happens over there. I'll let Cynthia or you, John, as experts to kind of talk about how widespread that would be felt and whether it would be different on the other side. I honestly don't know.
The slopes aren't as steep over there. There's greater ingress and egress. So I think it's safe to say that you're probably going to see less impact on that side. You would certainly feel it. It's really more as a matter of how far away are you from the epicenter. And, if you're in Driggs or Victor, you're probably going to be pretty close. Let's see. Is there are there plans for further trenching on the Teton Fault? There has been some other Ryan Thigpen, I know, is on. I think his team has done at least some minor trenching up in the northern part of the park, and they may, as I recall his talk, they had some other thoughts about that. Glenn Thackeray will be talking, I'm pretty sure, here if we do more of these Zoom talks in a month, and Glenn will address that question as well. They've done some small trenches as well, I know. Here's a question. Cynthia, I'll let you have first shot at this. Any data on Grovant River being another large landslide, dam breach?
I'm sorry, what was the question?
Are there any data on there possibly being another large landslide along the Grovant River or breach of the existing dam?
Not that I know of, but I don't know what the probability of a slide there is.
Nobody does, but
Yeah.
I would direct people to go look at the Wyoming State Geologic Survey website, and there's a hazards section to that. There's some very detailed mapping of existing landslides. It's very thorough, and what I suggest you will see, the landslides are colored in red. You will see that all up and down the Grovant River, there are a wealth of existing landslides. And are there data about another one happening anytime soon? No. Is it possible? Absolutely yes.
If you ask me, if you want to go look for a proto landslide, go drive south from Jackson toward Hoback roundabout, and just before you get to the roundabout, you'll feel your car go over a few bumps, and that's going to go one of these days.
Yeah, the Cretaceous is moving.
So I did throw a link for those that are kind of participating on the web in the chat to everyone. And most of you probably have seen this, but like John was saying, it's on the Geologic Survey website. They've got a great interactive ArcGIS map with the map landslides. But what's really cool that they've added are they've added a landslide susceptibility map. So they're actually starting to look at slope and soil type. And the resolution isn't super fine at this point, but I've talked to Seth Whitkey and John. You're kind of more in this circle of folks than I am. You may have heard something else about it, but I know that Seth said that Teton County is kind of the focus of higher resolution mapping with some of the susceptibility. And we used a little bit of the susceptibility mapping in our mitigation plan for some of the landslide hazards. And it's just great because it's interactive and you can kind of see where your house is. You can kind of see some of the places, spoiler alert, the whole map's red, everything except for like Jackson Lake is susceptible to landslides. But it is interesting to see. But yeah, playing with those layers and stuff is definitely worth checking out.
Here was a question, Rich, which I think you sort of already addressed, but that is, how will the county know if the Jackson Lake Dam fails?
So we have the Jackson Lake has there's an emergency action plan for Jackson Lake Dam that we practice twice a year usually with the Bureau of Reclamation, and then every other year there's a tabletop exercise that they put on, and all the communities that live along the Snake River that could be impacted by a failure of Jackson Lake Dam participate. Bureau of Reclamation actually has a really good emergency management program. So the process really is working through Grand Teton National Park and the dam manager, John Bennett, up at the dam, and his assistant, who I can't remember his name. And it's phone calls. So they have redundant communications at the dam, and their first notification is to Teton Interagency Dispatch Center. And then they immediately notify Sheriff's Office Dispatch and Emergency Management. We've got several outdoor warning sirens that are located at Teton Village, Station 6 on Teton Pines, Station 2 in Wilson, and also down at Hoback that will be activated as part of that. And then we kind of mentioned the broadcast radio. We mentioned no all hazards radio. Those would be ways that we would get messages out as well. And then, of course, the wireless emergency alerts.
Okay, I have a note saying that Ryan Thigpen, who's on the call on the program here, would like to say something about trenching. So I'm going to try and unmute. I can't. Brent, can you unmute Ryan?
Yep.
Go for it. You're not unmuted yet.
Just a second.
Now you are.
Yep. Can you guys hear me?
Yep.
Okay. Yep. We've just been funded by the National Science Foundation to start a new project in the Tetons this year. Hopefully we're going to get to the field, but of course that stuff's all up in the air. All of the trenching that we've talked about so far has been on land trenching. So there are trench sites that are like the one Cynthia talked about at Buffalo Bowl, at Cascade Canyon. There's a new trench site that Glenn Thackeray and his guys have been doing at Lee Canyon. So there's a whole bunch of these onshore trenches. And one of the challenges with them, I think, is that the trenches tend to be pretty weathered, and it's sort of difficult to make interpretations and get data out of them unless the slip events are quite large. And so what Darren Larson's team did at Jenny Lake is sort of state of the art. It was kind of developed by a European team that working in the Himalayas to fill the seismic gap to look for earthquake deposits in lakes, because lakes have so much better preservation records than onshore because they're not being weathered and turned to regolith and dealing with all those problems. And so one of the first big study that came out of that was Darren's. I think it's being published right now for Jenny Lake, but we're going to be doing cross fault transects in the north part of the lake. So the Teton Fault actually jumps Jackson Lake right about Wilcox Point and crosses over to Steamboat Mountain, where the active fault scarps are that Glenn Thackeray's team has trenched. He trenched it with Mark Zellman a couple years ago. And so there's a big scarp up there. And so what we're going to try to do is use a very specialized lake coring system to penetrate the Teton Fault segments that are actually in Jackson Lake up to the north. Now, the challenge is the Snake River Delta comes in and dumps all this really coarse sediment that's actually quite difficult to core through, but we're gonna give it our best shot. So my colleague Mike McGlew at University of Kentucky, who I'm working with on this project, is a world-class lakes coring expert. And so if he can work his magic, we're hoping to pull cores through the lake this year and hopefully get a higher fidelity record of the seismic slip events. We're sort of in a situation where we're looking at a seismic gap. We don't know if there's truly been no seismicity, or if the record of seismicity has been erased by weathering or erosion or whatever that's happened at these trench sites. And so our hope is that we're going to be able to core these active Teton Fault segments. I should mention that a couple of years ago, we imaged these segments using seismic reflection. So we've got maps of where the segments are in the north part of the lake. And this season, if the pandemic will let its foot off of us, we're planning in August to be out there collecting these cores.
Okay, thanks for that very much. Let's see. We're at 7 o'clock.
I have one last question for Rich.
Sure, go for it.
Minor detail. This person was asking, is it, in the event of an emergency, is it better to have a landline or a cell phone or both?
Great question. It depends on your emergency. So in a power outage, yeah, landline is the best, and not a cable telephone, because that will go out too. I'm talking actual copper, CenturyLink. I'm not plugging any company. It's just the only company that provides copper phone service here in the valley. That will work during a power outage. The disadvantage, of course, with phone lines and things during a seismic event is that they could be damaged and they could be ruptured, depending on if those lines run over faults and things like that, or landslide paths. There's all sorts of things that could impact them. But what we have to remember is that even with a cell phone, eventually that cell tower has to get to some kind of physical infrastructure. So the cell tower has to eventually get to fiber, it has to eventually get to copper, it has to get to something to get those communications back to the network and then complete your call. on the other side. So the single point of failure tends to be, some type of fiber or copper line. It could be a cell tower going down, but eventually they're all running into them. So for power outages and stuff, copper phone line is generally the best. We maintain 3 copper failover lines here at our emergency operations center. Our primary phone system is a voice over IP system through the county, and then we also maintain satellite phone, and then we have cell phone routers. So we utilize backups through several first responder cell phone networks to maintain communications down here. Satellite can be a good option, but it's expensive. So if you want to definitely have something, satellite phone is the best, and they have hybrid satellite phones out now that actually are both cell network and satellite, and it'll switch over dynamically. We don't have something that fancy. We just have a regular sat phone. But those are some of the backup communications. And then make friends with a ham radio operator. They will be able to communicate no matter what. They give them a car battery and a length of wire, and they will find a way to talk to somebody on the other side of the planet.
So another real quick question: in an emergency, is texting better than calling? I think that's a quick answer.
Yeah, it is. So generally the text takes up less bandwidth on the cell tower. So definitely text folks. The other nice part about texting somebody during an emergency, when you're in the middle of an emergency, it's a stressful time. Those that have been in high stress situations know that there's things called auditory exclusion. Your body actually starts to shunt blood to certain parts of your body, and you stop hearing things, and you get tunnel vision, you get things like that. So if you're relaying information to a loved one over the phone, they may not hear or remember what you told them. A text message, they can go back and read it later, right, after they've kind of calmed down. The other thing is, if you're making phone calls, if you are trying to make a voice call, generally you'll have an easier time making a successful phone call if you call long distance versus calling local. So long distance works on different circuits than local does. Immediately after an emergency, everybody's going to call their loved ones, their kids, mom, dad, grandma, everybody that lives in the neighborhood, right, to check on them. So you'll get the all circuits are busy. If you try to make the same call long distance, there's a very good chance that it'll get through. So that's why we recommend that in your family emergency plan, you have an out-of-state contact, so that everybody here in Jackson, if the big earthquake hits, they call, Aunt Gertrude in Kansas, and they check in with her and say, hey, I'm okay, I'm at school, or I'm okay, I'm at work, or I'm okay, I'm heading back home from grocery shopping. And Aunt Gertrude in Kansas can relay those messages to people as they call her. And so the long distance tends to work better.
Okay, it's 7:05 right now, so we've been going for a little over an hour. I think we're going to go ahead, and I don't see other questions right at the moment anyway. I'm going to go ahead and say that we're at an end here. I'd like to thank Cynthia for making the presentation. There's a lot of work that goes into that. And thank Rich for joining us and being willing and able to answer a lot of questions. The only thing I would like to ask our participants that are still on the line, and they've been dropping off here, is if you would send us a little bit of feedback here in the next day or two as to how you think this went, whether it was worthwhile. Should we try and do something like this again? We'd appreciate it. And you can do that. Some of you have my email address, or John Willott's, or somebody else's, Cynthia's. Go ahead and send it there. Otherwise, you can go onto our Geology of Jackson Hole website, and you'll find an option there to send a text to us through the website.